Hello everyone, today I will explain how to draw the pole zero plot of the transfer function. Suppose this is a transfer function given and we have to draw the pole zero plot of this transfer function. How will find? First of all, we have to consider the coefficients of numerator and denominator. In case of numerator, s to the power 2 its coefficient is 1, s to the power 1 its coefficient is 6, s to the power 0 its coefficient is 15. So numerator coefficients are 1, 6 and 15. Similarly, in case of denominator, s to the power 3 its coefficient is 1, s to the power 2 its coefficient is 7, s to the power 1 its coefficient is 9 and s to the power 0 its coefficient is 21. So denominator coefficients are 1, 7, 9, 21. Okay. Now open MATLAB. Type in command window for numerator num equal to, in square bracket type all the coefficients of numerator 1, 6, 15. Close this square bracket, put semicolon. For denominator den equal to, in square bracket type all the coefficients of denominator 1, 7, 9, 21. Close this square bracket, put semicolon. For system SYS equal to TF in parenthesis type NUM for numerator, comma DN for denominator. Close this parenthesis, put semicolon. PZ map in parenthesis type NUM, comma DN. Close this parenthesis, enter. Now we have got the plot of pole 0. Okay, so we can see here there are 3 poles. One pole is this one, here one pole and here one pole. We can bring the cursor to particular pole and we can find the value of pole. Similarly, we can bring the cursor to particular 0. There are 2 zeros, one 0 is here and another 0 is here. We can bring the cursor to particular 0 and we can have the value of 0. And we have a command also for finding the pole 0 value, that is in square bracket type z comma p, close this square bracket, equal to tf2 zp in parenthesis type num for numerator, comma den for denominator. Close this parenthesis, enter. So we can find the values of zeros as well as pole. In this way, we can find the pole 0 plot and we can have the value of poles and zeros. This is another example and we have to draw the pole 0 plot of this transfer function. We can see here numerator having 2 terms, s plus 2 and s plus 4. Similarly, denominator having 2 terms, s plus 3 and 2s square plus 6s plus 12. We have to make this numerator to single term and denominator to single term. How will make? We have to multiply. And in case of MATLAB, we have the command like this: numerator num equal to conv, start the parenthesis, in square bracket write first term, that is 1 2, comma in square bracket write second term 1 4, and both terms will be enclosed by parenthesis. Similarly, denominator den equal to conv in square bracket first term, comma square bracket second term, and both terms will be enclosed by parenthesis. Okay, in this way numerator and denominator can be converted into single term. Okay, now open MATLAB. Type in command window num equal to conv, start the parenthesis, in square bracket write first term of numerator 1 2, first term coefficients 1 2, close this square bracket, comma second term coefficients in square bracket type 1 4, close this square bracket, close this parenthesis, put semicolon. For denominator den equal to CONV, start the parenthesis in square bracket type, first term coefficients of denominator 1, 3, close the square bracket, comma, type second term coefficient in square bracket of denominator, that is 2, 6 and 12. Close the square bracket, close this parenthesis, put semicolon. For system SYS equal to TF in parenthesis type NUM, comma, DN. Close this parenthesis, semicolon. PZ map in parenthesis type NUM, comma, DN. Close this parenthesis, enter. We can see here the pole 0 plot, that is there are 3 poles. One pole is this one, here one pole and here one pole. Okay, so we can bring the cursor to particular pole and we can have the value of poles. Similarly, we can bring the cursor to particular 0 and we can have the value of 0. Okay, and we have a command like in square bracket type Z, comma, P, close the square bracket, equal to TF2 ZP in parenthesis type NUM, comma, DN. Close this parenthesis, enter. So we can have zero's value as well as pole's value. In this way, we can draw the pole 0 plot and we can find the value of poles and zeros. Okay, thank you.